Hello, welcome back. In this chapter, let's learn functions with C++. This is what we will be covering in the chapter. What is a function? A function is the predefined block of executable code that provides solution to smaller or micro tasks. Functions are invoked within programs and can be reused by one or many programs. A program can send values, or parameters, into the function for processing the task, and the function can send the processed result, or return value, back to the program from where it was called. Functions are one among the few building blocks of C++ where all program activity occurs. Using functions, we can structure our programs in a modular way. This is the syntax for usage of a function. And here is an example of the function definition. In the given example, a function named fn executes some program statements. It makes use of two incoming integer parameters I and j for computations, and finally returns an integer value val as the result to calling program. However, it is not necessary that a function has to send parameters or return a value. For a quick understanding, I have written the code for a function named prod, which when called by a program, executes the task of multiplying two numbers. A program will have to send the two integer numbers called parameters to the function for being multiplied. For example, a program would call the prod function like this. Prod 15, 10. It means 15 and 10 are passed to the function named prod, the numbers get multiplied with each other, and the product 150 is returned back to the calling program. Here is how the prod function is defined. The function receives two integer numbers through variables named a, b. Processing is done. Here it's the multiplication of a and b. Processed value, that is the multiplied result, is returned to calling program. I am now going to demonstrate how the function works. Suppose there is a bigger program with several functions. This program needs to find the product of two numbers at some point within it. Then this program will invoke the prod function that we just wrote, along with the two parameter values, 15 and 10. Program control then shifts to the function named prod. Remember that a function can be written within the same program file, or within other external files. The first parameter 15 is passed from the main program to the first parameter location at a in the function. The second parameter 10 is passed from the main program to the second parameter location at b in the function. 15 and 10 are assigned to a and b respectively, and the product is obtained. This product is then assigned to m. Remember that m is a variable or memory location where integer value can be stored. We then have this return statement in the function, which means that the value in variable m has to be returned to the program from where the prod function was called. So the program that called the prod function now gets back the processed result. This is how the function operates. Types of functions. Number 1. Functions with no parameter and no return value. Number 2. Functions with no parameter and with return value. Number 3. Functions with one or more parameters and no return value. Number 4. Functions with one or more parameters and with return value. Function declaration. It informs C++ compiler about the function to be used in a program. It has a function name, return type, and parameters. It ends with a semicolon. In most compilers, function declaration is not a must if the function definition comes before main function. This is an example of a function declaration. Function definition. It provides the actual functional code to a function. This is an example of the function definition. Program 39. Using function, print the sum of two numbers. Pass two integer parameters into the function, which returns sum of the two numbers. Here is the program code. I have defined a function named prod. It's declared before the main function. When you run this program, the control enter main function and onto line 11. An integer variable p is declared here. Memory is allocated. Program control shift to next line, where the prod function is invoked. The function is supposed to bring back some value and store it in the integer variable p. The prod function carries along with it two values, 15 and 10. So now, the program control jumps to function named prod. It carries along with it the two values, 15 and 10. 15 is auto-assigned to the variable a. 10 is assigned to variable b. Control then shifts to next line. Integer variable m is declared. On the next line we have asked to multiply a and b. Result is stored in m. And then the return statement returns the value of m to the calling portion. So next, program control goes back from the function to where it was called from. It carries along with it the value 150, which is assigned to variable p. On the next line, it's instructed to print the result onto output screen. We have the result printed, and the program ends. Scope of variables. The scope of variables declared in a function is restricted to within that function, and cannot be used outside it. Variables that are only accessible within functions are called local variables. In program 39, it is impossible to use variables a, b, or m directly within main function, since these variables are local to the function prod. Similarly, it is impossible to use variable p within the function prod, since it is a variable within or local to main function. Variables that can be accessed from any part of the program code are called global variables. Interaction between variables. As learned earlier, function is a predefined block of code that provides solution to smaller or micro tasks, and they can be reused by one or many programs. Programs interact with functions by calling a function at specific point of the program to perform certain tasks. When a function is called or invoked, the program may send values as parameters into the function for processing, and the function may return a value or result back to the program. Passing of parameters to the function is carried out by these common methods. A. Call by value. B. Call by reference. C. Passing of pointers. D. Constant parameters. E. Default arguments. Let's now look into each one of them. A. Function call by value. In this method, parameters are sent to a function as actual values. Within the function, these values are copied into variables that are local to the function. Any changes made to these variables in the function do not get affected in the main or parent program. Program 40. Initialize an int variable. Print it. Pass it to a function using call by value. Increment it. Print it from function. Return back to main program. Print the variable. This is the program code. And here is the function definition. The function is named fn. On program execution, the integer variable n is declared. Its assigned value 22. On line 11, we instruct to print value of n before function call. It's printed as 22. Then on line 12, the function fn is invoked. The value of n is also passed to the function. So the control jumps to function fn, where another local variable n is allocated memory space, and the value of n, carried from the main function, is auto-assigned to the variable n, which is local to the function named fn. Program control shifts to line 5. Value of n is increased by 1. So n now becomes 23. The next statement prints the value of n from within the function fn. It's 23. Since the function ends here, program control returns back to the main function from where it was called. The function is already executed, and so control shifts to next line. Here we print the value of n. Note that the value of n, which we increased by 1 inside the function fn, is no longer relevant inside the main function. So value of n, inside the main function, that is 22, is printed. We will now look into the function call by passing the reference. In this method, parameters are sent to a function as memory address location of data variables. Hence, it is the actual variable that is passed to a function. A change of value within the function of this actual variable will change that variable in the main or parent program as well. Program 41. Initialize bank account balance with certain amount. Accept deposit amount from user. Add it to account balance using call by reference function, and print the final balance in main program. Here is the program code. And this is the function. It's named fn. Program control enters the main function. Stops at line 9. Two float-type variables, balance and deposit, are allocated with memory space. Balance is assigned the value 100,000. On next line, we ask to print the account balance. It's printed on output screen. On next line, the user is prompted to enter a deposit amount. I enter 200,000. It's stored in variable deposit. On line 13, the function fn is invoked, with balance and deposit as parameters to the function. Program control shifts to the function. Value of deposit is carried along to the function, and is stored in variable d. Now the important part. The parameter balance is accepted by the function as ampersand of b, that is, as address of b, or reference to b. In simple terms, it creates a connection to the variable balance, and so the b within function would point to balance within main function. Program control shifts to line 5. It says, add value of d to the value of b. 200,000 is added to b, or where b is pointing to. And that is in the location balance. So balance now becomes 300,000. The function is complete, and program control returns back to where the function was invoked. Then on to next line. Updated account balance is printed on the output terminal, and the program comes to an end. We will next look into the function call by passing of pointers. In this method, parameters are sent to a function as pointers. This is similar to the call by reference method. As learned earlier, pointers are variables that store the address of data variables. Pointers can be passed as parameters to a function, or can be returned from the function. Change in value of the actual variable will be affected if it is changed within this function. Let's learn it with an example program. Accept two numbers and swap them. Display values before and after the swap. Here is the program code. And this is the function named exchange. Program control enters main function and onto line 12. Integer variables named a and b are declared. Memory is allocated. On next line, it's prompted to enter two numbers. I enter 77 and 0. They are stored in locations a and b respectively. On next two lines in the program code, we command to print the initial values of a and b. It's printed on output screen. Program control next shifts to line 17, where the function exchange is called, where parameters a and b are passed in the form of their memory address. Control jumps to function exchange. Pointer p of this function gets connected to variable a of main program. Similarly, pointer q gets connected to variable b of the main program. Control shift to line 5. Memory for int variable t is allocated. T is assigned the value that pointer p is pointing to. Value of location where pointer p is pointing to is changed to the value pointed by q. And finally, the value that pointer q is pointing to is changed to the value within t. Function execution is over, and so the control returns back to main function from where it was invoked, and thereon to the next line. Values of a and b, after the swap, are printed on screen. And the program ends. We will next have a look at the function call where a constant parameter is passed as the value. In this method, constant values are sent as parameters in a function. These values can only be used for computations, and cannot be changed by the function. For example, value of pi in maths. The keyword const is used to represent a constant value. The compiler generates an error if the function modifies a const parameter. Let's try it with a program. Calculate the area of a circle. Here is the program code. See the difference we have in this program. Note that for function definition that comes after the main function, remember to add function declaration before the main function. So in this program, here is the function definition. It's after the main function. And hence note that on line 3, we have had the function declaration. On program execution, the user is prompted to enter value for required radius. I enter 10. On line 11, the program invokes function named area. Value of radius, and constant value of pi, is passed to the function. Area is computed and returned back to main function. Finally, the area of circle with radius 10 is printed onto the output screen. Let's next look into the function call by passing of default arguments. In this method, parameters are sent to a function as replaceable default values. Here, total number of parameters needed for a function may or may not be sent. The function can be invoked using parameters lesser than total number of declared parameters. Any missing parameter assumes its default values. Default values are specified when the function is declared. It is used in situations where values of some arguments remain same for maximum instances. Default values are considered for parameters from right to left in the function call. Program 44. Use functions with default argument values to calculate the amount of interest. Get principal amount, time period, and rate of interest. If the customer specified time period is less than 1, then time equals 1 year. Similarly, if rate of interest is less than 3, use flat interest rate of 3%. So here is the program. Function named interest is defined at the bottom, and so it's declared before the main function. Note that in the function declaration, we have declared the default value for time as 1, and the rate as 3. It simply means that if no value is passed for time, it is by default assigned 1. Similarly, rate will be auto-assigned 3. Note that in this program we are going to calculate the simple interest by the formula I equals P times T times R divided by 100. Program control enters main function. Float variables are declared to store the principal amount in PA, time period, in T, rate of interest in ROI, and interest in I. The user is prompted to enter value for principal amount. I type 100,000. It's stored in PA. When prompted for time period, I type -1. It is stored in T. For the rate of interest, I type in 1. It gets stored in variable ROI. On line 10, it is checked if the time is less than 1, and the rate of interest is less than 3. Time is -1, and rate of interest is 1. So, yes. Both these conditions are satisfied. Program control enters the if condition. Value of T is changed to 1, and value of ROI is changed to 3. Remember that this is as per the requirement stated in last 2 lines of the program description. On line 14, we call the function named interest. We pass only the value of principal amount to the function. Whatever value the function returns will be stored in the variable I. Program control moves to the interest function. This function call is carrying along with it the principal amount. So the value 100,000 is copied from PA in main function to the variable named amount in the function interest. Memory is allocated for time and rate. Note that this function call has carried only the principal amount, while it needs to carry 3 parameters, as per the function declaration and definition. But we had mentioned in the function declaration that default time is 1, and that the default rate of interest is 3. Hence in the function named interest, value 1 is assigned to variable time. And value 3 is assigned to rate. Program control now shifts to line 37. The float variable, interest amount, is declared. On line 38, we calculate the interest, and assign the result to interest amount. It's 100,000 multiplied by 1, multiplied by 3, the whole divided by 100. And that is 3,000. On next line, the interest amount is returned. Program control returns to line 14 of main function, and the amount it carries along with it is stored in the variable I. Remember we are in the if condition, and it's the end of this if condition. So program control jumps out of the if block and reaches line 30. All values are printed, and the program terminates. Similarly, we enter values where only the rate of interest is entered wrong. Then we test with only the wrong time. And finally, we test with the right time and the right rate of interest. In this final case, no default value is assigned to the function variables. Play around and try testing with different values. Notice how the default values are assigned automatically. Let's next learn about the inline functions. Inline functions are mostly short, quickly executable functions. Keyword inline suggests C++ compiler to insert the function within a program. They are expanded inline, or at current location, wherein the function call is replaced by the function code. In inline function, the program control is not transferred from main program to the function. Instead, function statements are executed right in the main program, where that function is called. It is used to save time when small or micro functions are called many times within a program. In such cases, time is saved, as there is no overhead of function call and return. Inline functions are not used in recursive functions, or when multiple static variables are required, as it occupies unwanted memory. This is the syntax for defining an inline function. And here is an example of the inline function, where incoming parameter age is checked if it's less than 18 or not. Let's try it in a program. So here we have program 45. Accept the full name of a person, and print number of vowels in it. Use inline function to check the vowels. This is the program code for you. On lines 4 to 18, we have defined the inline function named vowels. On program execution, the control enters main function. A string variable named s is declared. User is prompted to enter a full name. I type in Kylian Mbappe. It's stored in variable s. On next line we print total number of vowels in Kylian Mbappe is, and then invoke the vowels function. So control is now at this spot where we have invoked the vowel function. Since it's an inline function, control doesn't jump to the function. Instead, the function statements are executed at this very spot, the number of vowels is identified, and the result 4 is printed onto output screen. Let's quickly see how the function worked. On line 24, the function vowel is called. Value within s is passed as parameter to the function, where it's again stored in function variable s. We then declare an array named vw, which stores all vowels in small and capital letters. So they are 10 in total. We then take each letter from the name stored in string s until it's not \0 or the enter key. The for loop checks 10 times and ensures if each of the letter in string s matches any character stored in the array vw. If it matches, vowel count is increased by 1. Here vowel count is stored in variable tot. Finally, tot is returned and gets printed by the cout statement where the function vowel was called. Program ends. We will next learn a major C++ concept. Function overloading. Let's consider Mr. Kumar, an expert plumber, who is also a professional electrician, a certified draftsman, and an established singer. Based on the requirement and the tools provided, Mr. Kumar can perform any of these tasks effortlessly. In simple terms, this is function overloading, where the required function overloads all other functions of Mr. Kumar at real time. Function overloading is the process of overloading a function with multiple tasks. This feature allows a function to be redefined multiple times, with different parameters and return types, so that it could be reused to perform different tasks. This is possible by giving the same name to more than one function, and ensuring that their parameter types, or the number of parameters, are different. This ability of functions to overload is also known as function polymorphism or compile-time polymorphism. Polymorphism means having different forms. The correct function is invoked depending upon the data type and the number of arguments passed to the function. We will now see how we can implement function overloading in a program. Program 46. Using function overloading, multiply two numbers, divide the two numbers, and square a number. This is the program code. We have here three functions with the same name, operate. First operate function accepts two parameters of type int and returns the multiplication value. Second operate function accepts two float numbers and returns the division value. Third operate function accepts one int number and returns the square value. The compiler decides which function is to be called by examining the data types passed or the number of arguments passed into the function. On line 19, the function operate is passed with integer parameters x and y, and so the first operate function is invoked. In other words, the first operate function overloads the other two defined operate functions. Similarly, on line 20, the program calls operate function, into which float variables n and m are passed as parameters. Hence, in this case, the second operate function overloads the other functions. Finally, on line 21, the operate function is passed with just one value, an integer value. Hence this function call invokes the third operate function. Values are printed on screen, and the program ends. Next is recursion. Recursion is the process in which a function calls itself for repeating a task. It is useful in operations like sorting, repeated computations, etc. Let's have a look at how recursion can be applied to find the factorial of a number, n factorial. The formula to find factorial of a number, n factorial, is equal to n times n minus 1 multiplied by n minus 2 multiplied by n minus 3 up to when n reaches 1. So, 5 factorial equals 5 times 4 multiplied by 3 multiplied by 2 multiplied by 1. And that is 120. Let's now write program 47. Requirement is, using recursive function, find the factorial of a number. This is the program code. The function name is factorial. Program control enters the main function. Memory is allocated for long variable n. User is prompted to enter a number. I enter 4. It's stored in n. On line 14, we ask to print factorial of 4 equals. And then, the function factorial is called. It carries within it the value of n. Program control jumps to the function factorial on line 3. The value 4, that is passed as parameter to this function, is copied to variable a in the function. Control shift to the if condition. It's check if a is greater than 1. Yes, it is. So control enters the if condition and executes return statement. It says, return a, or 4, multiplied by factorial of a, minus 1, or factorial of 3. So now, control jumps to the next factorial function with a parameter value 3. Here again the if condition is checked. A is greater than 1, and so next factorial function is called with parameter a minus 1 or 2. Here too, the if condition is checked. Again, a is greater than 1, and so next factorial function is called with parameter a minus 1 or 1. This time, the if condition is not met, as a or 1 is not greater than 1. So the else statement is executed. It says return 1. So 1 is returned from function factorial of 1 to its calling function. Control goes back to the function factorial of 2 from where it had arrived. The value 1 is carried along, and it replaces the function call to factorial of 1. In this function, it says return a multiplied by 1 or 2 multiplied by 1. So, 2 times 1 is returned to its parent function factorial of 3. Here, the incoming value replaces function call to factorial of 2 and returns 3 multiplied by 2 times 1 to its parent function factorial of 4. In this root parent function, it says return 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 24. Program control shifts back to the main program where the factorial function was first called, along with the value 24. It's printed onto the output screen as factorial of 4 equals 24. I hope you enjoyed this program. Here is an assignment for you guys. Just try calling a function from another file. It's simple. Just write a function, say example function, in another file, say testing.h. Then, include testing.h within double quotes, in a program named result.cpp, and call the example function. Try it any way you like. So with this, we come to an end of the chapter on functions. We will meet in the next video session. Until then, take care, and have a nice time.